Hello everybody, this is Jasmina, and in this video I'm going to talk again about compasses. And I want you to understand the limits that compasses have, especially today with all the electromagnetic interference we have from electrical lines inside and outside the house. So we know when the compass was invented, and we know when Feng Shui was invented or discovered. And Feng Shui began before the compass began. So we know that Feng Shui originally did not use a compass. And unfortunately, if you live in an urban environment, a suburban environment, your compass honestly is garbage in terms of telling you directions. Your GPS doesn't use a compass. Your GPS uses a satellite signal. And believe it or not, actually, to get you to where you want to go, we actually have to use uh, relativity because the satellite is moving faster than you'll ever be moving, and to get you to the right place. There's a tiny error, but it's enough that you actually have to use relativity. So that's pretty cool. And without us understanding relativity, we wouldn't have GPS. Now, compasses, whether they are physical, like the old style compass, or in your cell phone, it can't sense the difference between the Earth's magnetic field and the magnetic field from all the noise, all the electricity running through the wires. Because when electricity runs through wires, it creates a magnetic field. That is physics. And so it just can't tell the difference. It's just reading whatever is there. Even in rural areas, you have to make sure you're far enough away from any electrical wires. And really, you also have to be worried about, did somebody bury a tractor here? Or did a tractor get buried somewhere in this, on this hillside because of a landslide or something? Any big chunk of metal can also affect the magnetic field locally. And so this also is true of ore, like metallic ores, but that's pretty rare. Now, if you know what a declination is, congratulations, because a lot of people don't understand this, but it's basically just the difference between the magnetic north and the true north. And that does make it another step that you have to contend with if you're going to try to use a compass. So you have to, at the very least, you would have to correct for declination. But unfortunately, that usually does not give you the right answer, because the declination number you get from, let's say, NOAA, the government agency NOAA, is assuming you're out in the wild. This is supposed to help you actually be able to use a compass out in the wild to give yourself direction. So it doesn't really work in the city. Now, many ancient cultures understood what true north is by looking at the stars, and it's especially the North Star. Now, it's not exactly at the north, it's not exactly lined up with the north, uh, with the Earth's axis, that we spin around. But we know at a certain time of year where, and a certain time of night, exactly where the north is compared to the North Star. And there are plenty of cultures that have built buildings lined up to the north-south axes. This has happened in in like Mexico long before the the Europeans came, and also in other parts of the Americas. And Stonehenge has some very complicated uh, astronomical thing. And there are places in China that have done this too. It's wherever you could see the North Star. It was pretty easy for them to do. Now, in the Southern Hemisphere, you have the Southern Cross, but that is not as obvious. And I think this is one reason why cultures in the Northern Hemisphere advanced sooner than those in the southern hemisphere because we had a really good marker for where north is, so we could navigate and know where we were and get back to home, basically. Now, before the compass, Feng Shui was used only by the emperors and other very high and very rich officials. So it wasn't used by day-to-day people. And of course, I'm 100% sure that Feng Shui masters knew how to use the North Star because this was part of so many cultures. Now, some people would prefer to use a compass because they believe it is a lot easier than determining true north. You certainly can get a reading, but that reading can be literally garbage. That's the problem. And many of the practitioners that do this say that, oh, just use the compass. They also like to use the move-in date to determine the period, even though the house was not um, unoccupied for very many days. But it's a lot easier, I agree, but it can easily be incorrect. Now, I have a feeling they say this, just use a compass, and when you find things aren't working, you you have at least a certain chance of somebody is going to say, I need some help. I obviously am not doing this right, blaming themselves rather than the bad directions. And so this is maybe one way of drumming up business because the things you tell them isn't going to work. And they know it. And once you actually come there, they'll say, you just read this wrong. Of course, they're going to use true north, or at least close to it, at least UTM north. So the method that I've already gone through and shown you several videos that to determine true north is the only way I know how to do this in a pretty simple fashion. And that's because I do a calculation for you. It's basically a three-step process. You find your house on a satellite view, and you find its latitude and longitude. So that's the basic information for the house. That's step one. Now, this is actually where I live. This house with the dot on is actually my house. And it is, and so what you need to do is you need to draw a line along the edge of the roof. You want to do it where you know that it's more or less at the same level. And so I know how my house is built. Nicely, this is a morning shot. So you can see that this line right here is really distinctive. We have the shadow and then we have the brighter roof. This is what I would always prefer to use, something that I can really see clearly. And so what I would do is I would draw that line there. And so that's what this green line is. It's not terribly easy to see, but it's there. And then we know that in a satellite image, UTM north is always up in the image. So we draw a line that's parallel to the edge of the image, and that is UTM north. Now, I do this in the computer, so it's pretty easy, but then I also because the way the program works, I have to determine an angle that is less than 180 degrees because the computer doesn't like, or the program doesn't like to do it more than that. So that's why I do a 90-degree angle, which this is 90 degrees from the red line to the black line. And if we look close up, this is what it looks like. So this is 119 degrees. Now, that's not the angle because I'm missing this 90 degrees, this right there. So if I add that 90 degrees so that I know the measurement from UTM north, my house faces 209 degrees UTM. Now, that is usually pretty close to what your true facing direction is. What you need is to go to my website with your latitude and longitude and go to the calculator tab and stick in your latitude and longitude. It will give you, after you've done both and hit return, it will give you a number. For our particular house, it's super tiny. This is so small you can't measure it. So this number can be ignored. We happen to be very close to the center of our UTM grid. And I talk about that in a lot more detail in another video. But this is so small, we don't have to worry about it. However, yours can be over 2.5 degrees without too much trouble. And it could be, at least in theory, as much as 3 degrees. But it's usually closer to 1 degree. Now, if you want really high details, I actually have this video that will tell you in great detail with houses positioned in different directions of how you would actually find that angle that you need to do. And then you would go to the calculator. It will tell you whether to add or subtract a certain number. And then you do that. Then you know how far off you are. Now, in our case, I can't even draw that difference. That's so tiny. It makes no difference. But other places it does. Now, this is the facing direction from true north. Once you've done this correction, this will help you determine the facing direction from true north. And this is what you need to find your correct charts. Now, 3 degrees is enough if you are close to the edge between two different facing directions that it can change the facing direction of your house. So this is why you need to at least know what this number is. If it's less than 0.5 degree, I wouldn't worry about it. You can't really measure that accurately in an image like that. A surveyor can measure much more accurately. Now, many people do understand what declination is, and some think it can be used to properly measure a facing direction of a residence. But I'm sorry, today there's so much electromagnetic interference that it's really not practical. It's certainly not practical in a really crowded environment like at an apartment, especially a large apartment. I can almost guarantee you it has no relationship to reality, your compass reading. Now, declination again is the difference between true north and the Earth's magnetic field in any given location. So this will change depending where you are on the planet. Now, unfortunately, compasses, whether it's a physical old style compass with an actual needle you look at, or in your device, and your device has a little magnetic needle inside, that's how it works. It can't distinguish between the Earth's magnetic field and the magnetic field created by electricity moving through wires. There's where this is the heart of the problem. So I have taken some measurements to show you the issues that trying to do this creates, trying to use a compass without looking at a satellite view. So you can find your declination. I don't know if it's for the whole world, certainly for the US, at your particular location that is at a certain given latitude and longitude by first finding this, and this is not hard to do. Even the Google Earth or the Google Map will do this for you. And then you can go to this NOAA website. This is a US government entity like NASA, but it's NOAA. And it actually has a calculator that will do this for you if you put in the latitude and longitude. And it will return a number, and it's local. I call it local because I don't know how big their grids are. I'm sure it's not down to your house. I don't know how large the grids are. They're probably fairly large. And you will see it has an error range and a statement of how much it changes every year. So for my location, it is 9.25 degrees, and it would tell you north or east or west of true north, and plus or minus 0.35 degrees. So that means my declination may vary as less than 9 up to over 9.5. So that is a pretty wide range. That's, that can make a difference when you're at the edge between two facing directions. And it also says it changes 0.1 degree every year. So if you're relying on your compass, over time, your house will actually change its direction if you actually believe that, and your house hasn't moved. That also does not make any sense. Now, the true facing direction of the house using my method we know is 109 degrees. The declination according to Noah is this. So I took a reading outside with a physical compass because my tablet doesn't have my tablet and my husband's cell phone doesn't have a SIM card that has data. And so we rely on the Wi-Fi. And when you go outside, you lose the Wi-Fi. So I had to use a real compass. And of course, I know how to use one because I'm old. So, I do know how to read a compass. And so it read at 204. Now, this is, a lot less accurate than looking at the satellite, but 204 is pretty close. Now, inside the house, it was 227 to 230, and it depended on whether or not our AC was running. The same 3-degree difference also happens when the heat comes on. So this is a proof of electromagnetic fields created by electricity running through the wire, changing your direction. And you can do this. You can look, I actually challenge you to do this and see how screwy your particular location can be, especially inside your house. Outside is probably going to be a little better. Now, correcting for declination would place a house at 213. It's only a 4-degree error, and since we happen to be pretty much in the middle of Southwest 1 facing, that 4-degree wouldn't make an error in the facing direction of our house. But if we were close to the edge, it would place us into a different facing direction. So it does depend on some of the details, and depending on how much electromagnetic interference you have from wires in your neighborhood, it can be larger than this. Now, at least that is half decent, that maybe you're going to get the general facing direction right. But sometime you really want to know, because some rooms are split by 2 different directions. You have to know the areas and which one has the most area. That's usually how you determine what is the whole room's energy. And 4 degrees difference will make a big difference in many houses. So this could screw things up. So if we add the declination to this reading, the smaller of the 2 readings, it would lead to a 27-degree error. And if the AC was on, it would be a 30-degree error. So that would really cause you to even back in the wrong direction if you would try to use this. It just isn't going to work. And you certainly would misplace mitigation items to mitigate, like Shachi and things like this, if you tried to use this. This is why you should not be using a compass, even if you try to add the declination or subtract it, depending on which the NOAA website will tell you to do. So the problem is that there's so much electromagnetic interference inside your house. It is impossible to trust a compass inside your house. So it is a good question. Are there conditions that you can correctly use a compass? Well, the answer is yes. If you are outside, far from buildings that almost always have power to them, and you cannot see any electrical or light poles, many parks in a city do have light poles. So maybe or maybe not that could work. It's a little hard to tell. You can still do a test, which I'll talk about in a bit, but You certainly do not want to be able to see an electrical pylon. A pylon is usually made out of metal, not wood or something that looks like wood for an electrical pole. They have four legs instead of just one, and they taper as they go up. So they very, very remotely look a little bit like the Eiffel Tower. Now, the lines that are here are extremely high-powered lines. The reason why they do this is a power plant, let's say a hydropower plant, is located somewhere where it's ideal to build a dam. That could be very far from a city. But if you have very high power, high voltage lines, they lose less electricity in their transmission. And that's why electrical pylons exist and why they're usually in the countryside, because they're going between a power plant and a nearby city or somewhat nearby city. Now, before these pylons get to the city, they will enter more buildings that are owned by the electrical company, where that high voltage electricity is stepped down through transformers to something that we use in our houses, to a voltage level that we use in our houses. But because these electrical pylons have lines that are super high power, they create a lot of electromagnetic disturbance. So that's going to screw up your compass. If you can see them, they might be too close. But there is a way to test this. It's a bit of a pain, but you can test this, especially if it's a place that's convenient for you to go to on a regular basis. Now, under these conditions, let's say you'd have no pylons, no electrical poles, no light poles, no nothing. You probably can use the compass even straightforwardly, but it's still better to check what your declination is in your general locality, because it can be quite large. It can be 20 degrees, because there are places on Earth where there are. And the farther north or south you are of the equator, the larger the error can be. So if you're near the equator and you're out in the middle of nowhere, yeah, you probably can just use your compass. And you can then back to a certain direction. Now, if you're going to manifest, you do not have to manifest inside your house. You can manifest outside. But your backyard is almost certainly not big enough, unless you are super rich, for you to be able to do this and not worry about electromagnetic interference, because there's just too much electricity all over the place, at least these days. Now, another way to know what true north is, and you can do this in a park, even if you can see a electrical pole or a pylon, you don't want to be too close to the pylon. You want to be as far away as you can be from that. But if you go to some place, and you can do this by entering, well, they usually only have it for a city, but you might be able to do latitude and longitude. From the time and date website, you can find out when solar noon is for your location. And then if you look where the sun is at solar noon for that location, you know that's south if you're in the northern hemisphere, or you know it's north if you're in the southern hemisphere. So that definitively will tell you what direction true north is, because that's based on the sun. So, and based on how our planet rotates around itself. So it works. That can be a way where you can be absolutely certain outside. But you have to be there at solar noon. So that can be a little tricky. But if it's a place you go to regularly, you know exactly where to face. Maybe there's a landmark somewhere that you may look at, and you know you're facing the correct direction. But you can also just see, especially if you don't have any light poles or pylons, you can then see how far off. Basically, you will know the declination at that location. So that can work too. Now, you can use your compass to properly position yourself for manifestation, perhaps for placing mitigations, depending on some details, but there you don't pay any attention to declination. What you do is you still have to first find your true facing direction, and then you point your device in that direction and see what it reads. It's very unlikely to read your true facing direction, but we don't care. We can correct for that. So you need to know the difference between your device's reading and what you know is your true facing direction. For example, when I measured the compass facing or from the tablet inside the house, it was 227, but I know my house faces 209. So I know that the compass is reading 18 degrees too high. So we can adjust for this. This is how you do the real adjustment. If I know I want to back to, let's say, northeast 2, that is 45 degrees, and this is a good thing in terms of if you're going to manifest, try to manifest to the center of that 45-degree sector, because then even if you move a little, you'll still be backing to the right direction. So if I know I want to back to 45 degrees, I know I want to face 225. So that's 180 plus 45. And this is in the true direction. So which means for me, I point the device away from me and I position myself, I be close to where I want to sit and do the manifestation. I would rotate until my device reads 143 or 243. That's the 215 plus the error of 18 degrees. And then you sit down, you put the tablet someplace else, sit down, backing that direction, and you're good. And now you know you are truly backing to 45 degrees, which is what you need to for, let's say, this given some given manifestation, you need to back to 45. So you can do that for anything. And what you're doing is you're correcting. So you can do this more easily than, okay, where do I have to actually be? You can do this easily with a compass, but you don't use declination, you don't use any of this. You still have to know your true facing direction. So this is an example. Somebody who wants to back, this down here would be backing to 45 degrees. It looks like 90, but it's not. And so you just rotate your body basically at your chair. And if you have a stool that is a swivel stool, it's even easier. And you wait until your device reads 243. And now you know, I mean, at least in our house, I would know that I am backing to 45 degrees. So if you are trying to place a mitigation in a certain subsector, and that most mitigations have to go into subsectors, you would use a similar process. You could do this with your device pointing away from you while standing in the center of your house, but you have to have a line of sight to do this properly. This is not usually how I would do this. When I do this, I use a floor plan, and if I'm doing this for others, I demarcate an area with measurements from the corner of a room. So from one corner, you go along this wall, this distance, and then you go perpendicular another distance. And this is like in the center of the area, the best place to place a mitigation. Now, there are some mitigations that require only a little over 5.5 degrees of accuracy. That's really tight. And really, you can only do this with a floor plan. And you have to have your house. You have to actually have your template that gives you your directions has to be properly placed. And so this is how I usually do it for people when I'm saying you need to put a mitigation here, and I tell them exactly where. And I give them a range. I told them you could do it anywhere in here, but this is right in the close to the center, best place for it. Now, you might ask why chi isn't affected by a magnetic field. And I don't know if anybody has thought about that, but this is an extremely good question. Now, all masters I've ever heard of agree that chi is energy. It's not a particle like a particular atom or something like this. It's energy. Anything that does not have a charge, like a photon, is unaffected by a magnetic field. Also, neutrons. You got protons, you've got electrons, you've got neutrons. Neutrons are not affected by a magnetic field because they have no charge. So in theory, yes, there are some particles that also are unaffected by magnetic fields, but they also tend not to interact a lot, whereas electrons and protons interact a whole lot. Now, if chi were a charged particle, like an electron or proton, we would already know what chi is because charged particles are very, very easy to detect. In supercolliders, they detect this because these charged particles stream out, and you can tell which ones have charge because they curve in the magnetic field. There's something called a cloud chamber that way back when they were able to see that, yes, electrons and protons actually have opposite charges because they curl in a magnetic field in opposite directions. So we have really good handle on detecting charged particles. But nobody really knows what chi is exactly. But I do agree it is energy. Now, we know ultimately chi's origin is from our sun, because without sun, life would not exist on Earth, and there's no life force, no chi. So we also know that our Earth's magnetic field allows at least a lot of light to enter. Now, some of the atmosphere absorbs things, but that's the atmosphere, not the magnetic field. But not many charged particles get through. Mars used to have an atmosphere, used to have liquid water, but Mars is smaller than Earth, and its core, and on Earth, it's our core spinning compared to the outside that creates our magnetic field. But that core in Mars cooled down enough that it stops spinning with relationship to the to like within itself. It's basically become frozen. That had the magnetic field vanish from Mars. It probably happened over a certain period of time, but ultimately it vanished from Mars. And now all of the solar wind, which is really high energy charged particles that do stream out from the sun all the time, that blew away the atmosphere. The water kept evaporating, it blew away the water, and so now it's a lifeless planet. And we don't know if it ever had life. We are investigating. It would be cool if it did, but I don't know if we're ever going to find that. Now, because of this, we don't have a lot of charged particles making it to the Earth. So that's almost certainly not what chi is. It is part of the electromagnetic spectrum, is my guess. Now, examples of energy that are not part of a particle that is a charged particle includes photons. The visible and non-visible ones to our eyes. Other animals can see light of different spectrums than we can. Heat, the infrared heat, is also a photon. So this is almost certainly what chi is, part of this that comes from the sun. Now, I happen to believe that chi is a small slice of the photon spectrum. We haven't searched well enough to determine this because we partly don't know how to determine exactly what chi's effects on the human body is. And I think that more research could be done and we could ultimately find this at some point. And it's possible that different people have slightly different windows for chi. It is possible because we're physically different. So, different size, different mass, things like this. And so that, I think, sometime in the future, we may ultimately find. But doing this kind of research is extremely expensive. And so I'm hoping that China will do this at some point because they're getting richer all the time, and they do have enough money that if they wanted to do this, they could start looking. So I'm ending my diatribe on compasses. I really hate when people try to use a compass because I really think they're going to be wrong, especially if they live in an apartment. They're just so far off reality. And uh, if you still want to use a compass, I'm not going to say you can't. I'm just going to say you're probably wrong. So I really hate to be naggy, but I really think that you need to understand how chi works and why you should not use a compass. Thanks for watching.